I'm going to start off by saying that more and more of today's research contains software, code, algorithms, scripts. And when we see figures a lot of times within a research article, there is an actual algorithm, a piece of software, a piece of code behind that actual figure. And though the figure may be interesting in itself, more and more researchers now, especially in the pharma industry and the bioinformatics area, they actually want to see the actual code, the algorithm, or the piece of software that was used to produce that figure. And if that is what you actually want to do, the steps to doing that are extremely painful, right? I work for CodeOcean, and we are a group of researchers who are actually solving this problem in the actual scholarly publishing space. And it comes from experience. Our CEO, Samin Adar, was a spectral imaging engineer, and when he was going through the literature and trying to find code and algorithms, trying to reproduce those codes and algorithms in order to build on his own research, these are the steps that he had to go through most of the time. First, he had to find the code, because most of the time it wasn't actually in the article. Sometimes there's a reference to it outside somewhere. But most of the time the workflow, he actually had to email the PI or the author of record to ask them where the code was. Once they had the code, that was actually the easy part. Then you had to find the right hardware, make sure you had the right packages, and then a lot of times you would go in what people call dependency hell. One file depends on another file, depends on another file, depends on another file. And it's a huge headache for researchers to get code up and running. And so what we've created is a cloud-based executable platform that allows researchers to deposit their code and software, and then others are able to click it just by hitting a run button. And this really speaks to a lot of ways in the reproducibility. A lot of people are calling it a crisis that we're having. And this is actually from a survey, a very popular survey from Nature. What I thought was actually really interesting about this survey was not only did scientists have problems reproducing other scientists' work, many of them had problems reproducing their own a couple of years down the road, right? We know we have a problem when. And a lot of the reason is, in the very beginning, this speaker was talking, a lot of times in the very beginning, it's not because they're creating junk science or they're purposely being malicious or p-hacking or whatever. It's because when you're depositing your code on GitHub or other services that currently exist, they're just publishing the code, and it's flat code. And a lot of times the boring stuff that's really important to get it to run, like the shell scripts or the particular packages or the exact languages, are not being curated and saved, and especially, certainly not in an executable format. So this is what the interface looks like. I'm going to try not to blind you, right, with this laser, but on the left-hand side, I hope you can see that, an author puts their code and software files. On the bottom left, they input their data files, right? They can use the coding window in itself to actually code straight into the platform, right? They pick their languages. This happens to be in R. And then we're built based off two principal technologies, which is Docker and AWS. So they put all their data, they put all their code, and then they'll pick the right packages for their particular software to run. And then they can click the run button, and before they actually publish their software on our platform, it actually has to run and reproduce results, and then it goes through a small verification phase. And this is actually just an output file, and we've integrated some visualizations like Plotly to give the data a little bit more flair, or visualize it in a better way. So the idea is that this is a compute capsule, and we meant a DOI around this compute capsule of everything researchers need in order to run the code. But the interesting part is researchers can actually put in their input values, their own input values, and rerun the code, right? So it facilitates not only reproducibility, but reuse of code, right? So in the very beginning, when we were talking about, in order for you to build on top of science, you have to know that the science that you're building upon works. This is, at least for the computational sciences, this is an excellent tool. right? The other problem that we're solving is the gentleman from Mothia was talking about, is there's this dual system, right? Researchers in the article, they find a particular article that references code or data, they have to jump out of the article, out of the publisher platform, and go find it. And for most code, it's in GitHub, right? And so they're leaving the published article. So not only is this bad for the publisher because they're losing usage, but it's also bad for the user experience of the reader. Right? And so what we've created is a widget in the very same way that this is an iframe, very same way there's a YouTube widget, that so after someone creates a computational capsule, right, there's actually one more. Right. There is actually a share function there. You can get a piece of embed code, right, and you can drop that embed code. It's just simple HTML. You can drop it anywhere, and one more, and the widget will appear, right? And I've put some examples there. Hopefully you can grab the slides off the iPad that you're using. You can see that we've integrated with F1000, there's GigaScience, IEEE. So within the article, there's actually an iframe of the actual code, and authors can actually click the run button, or end users can click the run button and actually run the code. So these are a couple of questions I had. So this is a survey from the American Society of Chemical Biologists, or Clinical Biologists, right? And they were actually asking, so do I just, yeah?
Yep. Whenever you're ready, they'll start.
Voting time.
Thank you. Right, 70%. Wow, you guys are good. That is the answer. Right? Can I skip the next question only because of lack of time? And I will go right to my closing slide. I always like to say, I'm from the United States. I work out of New York offices. We're a Cornell incubated startup. Though we're not in Ithaca, we're in the city. I like to say I have a very distinctive name, but it actually doesn't work in this area of the woods, right? So I am at Pierre@codeocean.com. The platform's free. It's open. Codeocean.com. I suggest you go on it, check it out, and you can always get a hold of me for any questions. And my last little thing is we also are coming out in January 2018 with a peer review sort of overlay on top of the platform. So that's something to keep your eyes out for. Thank you very much.